Hello everyone, welcome again to yet another beautiful lesson, and you're with me Zaitwa Jwatula, your instructor, and in today's lesson I just want us to at least be more conversant and familiar with the half reaction equations, right? And this is now in the context of electrolysis. Of course, tikaona kusonkhani ama redox reactions kupanga so appreciate more, but then we're just going to be applying that knowledge yakuma redox reactions in this electrolysis, right? So we're assuming in this case we've used sodium, we have copper chloride, right? So we have the electrolyte here to the copper chloride. So if it is copper chloride, we know if it is in, let's say, aqueous state, something like that, right? Zipeze kwena kuti ma uje na metu kukhala nawo and we have copper, ma ions that we have copper ions, we have also ma hydrogen ajawo, something like that, and we know the things that to result into the preferential whatever, like we can easily predict going out. I think on the cathode this is what we're gonna obtain, and on the anode this is what we're gonna obtain as well, right? So on the anode side, or at the anode side, and this is where it is connected to the positive terminal of the battery, right? Ndipo metu kuena kuti ma chloride ions damene akutani akupitako, okay? Ma chloride ions damene akupangidwa attracted there, because in this case it's something to do with those other factors made now in terms of the concentration and all that, right? So for that reason we have chloride ions that are getting there, and yes, of course, what is happening is as they go there, they are losing their electrons, okay? So as they go there, they are losing their electrons, okay, like in this case. So we have this guy that is losing my electrons. So the electrons that are lost by these chloride ions akupanga move, and then akufika kujani ku cathode damene akumalandiridwa ndi chani ndi ma positive ions amene akupitawo, okay? And at the cathode, this is pretty much what is happening, right? So here let's take note of what is happening here. We have minus on this end, right? Have minus 2. This one is losing 2 electrons, and kwinaku ndomene ukhandijani at the cathode, since the ones that have been lost from the anode side will be the very same ones to be received on the cathode side. We have copper, okay? So for copper, sorry, let me just erase this. So for copper, chomwe tikukhala nacho ndichonena kuti ndamene akupangidwa favored as compared to other ions, and for that reason ndamene tikupeza kwena kuti akupangidwa attracted to the cathode side, okay? Akupangidwa attracted to the cathode side, and akapangidwa attracted to the cathode side ndamene akupeza kwena kuti akutani akulandira those ions, those electrons rather, amene anapangidwa lost ndi chloride, okay? And chifukwa kuti walandira nchifukwa kuti kuona papa there is a plus, okay? So Cu2 plus because of its position yaujeni ngakuti group 2, right? And walandira 2 electrons to form 1 copper molecule imene ili yachani, imene ili ya also yachani ya in form of like solid, kapena kuti ndi chitsulo chomwe chili cha solid. So what you need to be doing is you need to be dividing my chemical equations. At first you're seeing all this that is happening at the anode side, right? And then mwaonaso zonse zomwe zachitika kuchani to the cathode side, and then you need to bring these two together, two equations together, okay? And you need to do some cancelling pamene popo cholinga kuti khalendi the actual equation, because if you were to look at the previous lesson timangoona kuena kuti timangobwera ndi like half ndikubwera the overall yoena kuti yachitika chonchi, koma si tinaona kuona kuti chimachitika ndi chani, kuena kuti ma electrons ena chakodi apita kutiko, because do we just discard them? No, we need to bring all those things together, yapa cathode and yapa anode. Titakuona from this kuena kuti we have all this like part ina ya anode, part ina ya cathode. Komano since ku anode kucha tinabwera kuena kuti tikandi negative 2e kusonyeza kuti amaluza, okay, ngati uyu amaluza ma electrons awiri, and at the same time tabweretsanso equation ya ku cathode yomwe kuli plus 2e kusonyeza kuti winayo akupanga gain, and we know already kuena kuti minus plus and onse ndi 2e zingakwena kuti 2 minus 2, right? Then we are cancelling, so don't forget to cancel the electrons and balance the whole thing pamato pake. And what we are remaining with here, since we've cancelled the electrons, we have 2Cl minus, which is in aqueous form because anapanga dissolve in mazi, and we have Cu2 plus, which is in aqueous form, and pamato pake kwina wakupanga form gas, okay, and kwina wakupanga form solid. Okay, so that's pretty much what you're supposed to be doing, and I think if it is in a modern state, okay, you know already what will be happening. It's just pretty easier, right? Because you won't even bother with these preferential whatever discharge that is complicated as many to go in inai. Okay, so kukakhala zoena kuti let's say zilichabe mu modern form, okay, those ones that are in modern form pamene tikuona kuena kuti it's just simple and straightforward, right? We know already kuena kuti chikuchitika ni chan, it's the same thing yomwe taiona mwamba muchamo, only kuti the ions they just like give away, okay. In this case we have hydrochloric acid. So in the case of hydrochloric acid, what happens, right? So it means if it is hydrochloric acid, okay, it's just HCl, okay, and it's in modern form. Wina yakungopita kungati chloride, alright? Chloride akupita kwinaku akuluza my electrons, we are forming chloride gas, and at the same time at the cathode information kuti we are forming hydrogen gas, and kuphatikiza zonse, this is the thing that we have pake, okay, like the whole reaction. And from the principles I think it's just easier. I think it's just easier for you to predict, okay. So yes guys, that was it. Mostly pamete mafuna tuone like balancing the redox reactions kabena kuti half equations. This is also examinable, and you need to be trying them kuma ujenosiyana siyana kati ma compounds osiyana, and given kwena kuti it's something which is in aqueous form and something also which is, let's say, in modern form, something like that, we need to just be familiar with all those things, and trust me, my soul azakara opweka, okay. Yeah, so thank you, have a good day.